Whether screen is visible to everybody? Give me a feedback. Hello. Hello. Someone. Whether screen is visible to everyone? Hello.
Yes, sir. Yes, sir. Visible.
Okay. So today we are going to start advanced technical training related to the fluid mechanics on the topic called as the pressure and its measurement. So if you go through the syllabus, so in the IS syllabus as well as in the GATE syllabus, so there is one point called as the manometry. So that manometry is that manometer is nothing but the device which the help of which we are able to measure the pressure. So related to that one point only, here our unit 2 will be there, that is called as the pressure and its measurement. So under this topic, the points which we are going to cover, those are nothing but first point is nothing but what is meant by pressure. Then after that we are going to see what is meant by Pascal's law. After that we are going to see what is meant by hydrostatic law. After that we are going to see the concept of absolute pressure and gauge pressure. Then manometer. So we are knowing that there are two types of manometer, simple manometer and differential manometer. So most of the related to this unit 2, that is pressure and its measurement, is being covered in the class, but only problems related to this point, that means problems related to the Pascal's law, hydrostatic law, then absolute pressure, gauge pressure, related to the manometers, those problems are not being covered in the class because this manometer part was related to the practicals, and whatever remaining part was there, that was the basic part related to the fluid static. So, but in IES exam or GATE exam, question may be asked related to the manometers. That means problems based on these points. That means what do you mean? Problems based on Pascal's law, hydrostatic law, absolute pressure, gauge pressure, or manometers. Or sometimes related to the basics of these points also. The question may be asked for GATE exam or IES exam, or related to your technical aptitudes for the campus recruitment test. So we are going to brush up today. In the lecture, we are going to brush up all the knowledge related to this point, and after that, we are going to solve the problems related to this. So as these tasks are covered, so I'm going to go a little bit fast while going through these slides. So first one is related to the pressure. So before going to the definition of pressure, okay, first of all, we'll see the definition of pressure. So, pressure, we are knowing that pressure is nothing but the external force per unit area called as a pressure. So, in the song, you have studied the definition of stress also. Stress is also called as a force per unit area. And if you check the unit of pressure as well as stress, so unit of pressure is nothing but Newton per meter square. Unit of stress is also nothing but Newton per meter square. So as both of the pressure as well as stress is having the same unit. So whether pressure and stress is the same quantity, those are not the same quantity because pressure is there. In case of pressure, we are considering the external applied force. We are considering the external, the basic difference between pressure and stress. So in case of pressure, we are considering the external applied force on a unit area. That is called as the pressure. Whereas in case of stress, whenever we are going to apply the force externally on any body, so inside that body, the resistive force will be generated. So in case of stress, we are considering the internal resistive force generated. We are considering the internal
Sir,
resistive force generated. Huh? Yes, sir.
voice is kind of breaking.
What, sir? Voice is breaking.
Yes, sir.
Wait, I will change the microphone.
Okay.
Hello. Whether voice is audible, please give the reply in the chat
Yes,
box.
sir.
Also,
Yes, yes, no problem.
whether voice is audible.
Yes,
Yes, sir. So we are seeing the basic difference between pressure and stress. So we are knowing that pressure and stress both are having the same unit, that is nothing but Newton per meter square. So the basic difference between pressure and stress is nothing but in case of pressure, though we are finding pressure is nothing but force per unit area, but force we are considering the externally applied force on a unit area, that is called as a pressure. And in case of stress, so whenever we are applying any force, external force on any object or any body, so because of applying external force, there will be the resistive or there will be the generation of resistive force inside the body. So that is nothing but called the internal resistive force. So in case of stress, though we are finding as a force per unit area, but that force is nothing but the internal resistive force per unit area. That is called as stress. So you should clearly understand the basic difference between pressure and stress, external force per unit area and internal resistive force per unit area. So the quantity is having the same unit, that is called as Newton per meter square. So pressure, we are considering the unit of pressure in terms of MKS. So MKS means mass, kg, and second. So in case of MKS unit, we are considering the unit of pressure as a kg force per meter square or kg force per centimeter square. And in terms of SI unit, we are considering the pressure in terms of Newton per meter square. So here, Newton per is also called as a Pascal. Newton per meter square is also called as a Pascal. And here unit conversion 1 kilopascal is nothing but 10 raised to 3 Newton per meter square. And another unit of pressure is nothing but the bar. So 1 bar is nothing but equal to 100 kilopascal, which is nothing but equal to 10 raised to 5 Newton per meter square. So while solving the basic problems, you need to do the conversion of unit. So while converging the unit, whatever this border part is Pascal is equal to 10 raised to 3 Newton per meter square, or 1 bar is equal to 100 Pascal 10 raised to 5 Newton per meter square. This unit while converging the unit. Then second one is called as a Pascal's law. Pascal's law is also called as a force multiplication law. Is also called as a force multiplication law. So here, whatever Pascal's law is there, so Pascal's law is applicable only for the static fluid. Pascal's law is applicable only for the static fluid. Static fluid is fluid which is in rest. Now here you are observing that there is one piston cylinder assembly. So this is the piston part. This is the piston, and inside this piston and cylinder assembly, there is one tube. So here, with the help of this rod, we can apply the pressure on the piston. So according to Pascal's law, the pressure or intensity of pressure at any point in a static fluid is equal in all the direction. So as per the Pascal's law, the pressure intensity or pressure at any point in a static fluid is equal in all direction. The meaning of the same is nothing but if you are going to consider any point, if you are going to consider any point in this piston and cylinder assembly, and if you are going to measure the pressure intensity, if you are going to measure the pressure intensity at any point, so if that fluid will be static fluid, then according to Pascal's law, the pressure intensity at any point, in this static fluid will be same in all directions. So here there are so many applications of Pascal's law. So in force, as I have told you, another name of Pascal's law is nothing but force multiplication law. That is, by applying a smaller force, you are able to generate the larger force using the Pascal's law. So in terms of hydraulic machines, in terms of hydraulic jar, we are using that Pascal. So all the earth moving equipment, they are also using the Pascal's law. So here, whatever real life application is there, so we are connecting two cylinders. So suppose this is the first cylinder, and which is having the area as A1, which is smaller in size. And to this smaller cylinder, if I'm going to connect the larger cylinder, suppose this is the larger cylinder which is having the area as A2. So if I'm going to connect smaller cylinder and larger cylinder with the help of one pipeline, and inside this cylinder and inside this piston cylinder assembly, if I'm going to fill the fluid, which will be static. Now here on the piston, on the smaller cylinder, I'm going to apply the force as a F1. On the cylinder, if I'm going to apply the force as a F1, then automatically force will be generated at the larger cylinder. That is nothing but F2. And according to the Pascal law, whatever fluid is trapped, whatever fluid is trapped, that is called as the static fluid. So if you are going to consider any point in that static fluid, then intensity of pressure or pressure intensity at any point will always remain same. That means here, if I'm going to consider this as the point number 1, this as the point number 2, then according to Pascal's pressure intensity at this point, that is nothing but suppose P1 is equal to pressure intensity at this point, suppose P2. So here, as I have applied the force F1 on an area A1, then I'm knowing that P1 is nothing but equal to F1 upon A1, because pressure is nothing but force per unit area. Similarly, here as F2 force is being generated on a area A2, that's why P2 is nothing but F2 upon A2. So as this is the static fluid, so for static fluid, pressure intensity at any point always remains same. That means P1 is equal to P2. For static fluid, P1 is equal to P2. That is nothing but here P1 is nothing but F1 upon A1. Here P2 is nothing but F2 upon A2. So here by applying the force F1, we are generating the force F2. So if I want to calculate the value of F2, if I want to calculate the value of F2, then value of F2 will be equal to, here in this case, F2 will be equal to A2 upon A1 into F1. F2 is equal to A2 upon A1 into F1. So here we are clearly observing that value of A2 is much more, much bigger as compared to value of A1. So as A2 is greater than A1, as A2 is greater than A1, that's why force generated at the second cylinder is much more as compared to force applied on a smaller cylinder. So here, by using Pascal's law, by application of smaller force, here initially we have applied the force as a F1. By application of smaller force, we are able to generate a larger force. So this is called as a Pascal's law. Are you getting? Then second one is called hydrostatic law. It's called as a law. So whatever this hydrostatic law is there, so that hydrostatic law of the pressure intensity inside a fluid. So you are having a fluid. So any fluid, if you are going to consider this as a any fluid, and suppose is the screen is yes or no? Reply. Hello. Hello.
Hello, sir.
The
Voice
screen
is
is
still
visible.
breaking.
Still voice is breaking.
Yes, sir.
Hello. Now the voice is clear.
Yes, sir.
Okay. So whatever this hydrostatic law is there. So hydrostatic law is useful for finding out the intensity of pressure inside a fluid. Suppose in this diagram, you are observing that there is a static fluid. So whatever this hydrostatic law is there, that is also applicable for static fluid only. That means fluid which is in rest condition only. So this hydrostatic law as well as Pascal's law will not be applicable for the fluid which is in motion. So that basic point you have to remember. So here, suppose we are having a fluid which is stored inside the dam or the fluid which is stationary, and I am considering this as the free surface of the fluid. If I am considering the free surface of the fluid, and if I want to find out the pressure intensity acting on fluid element at any point, suppose at this location, at this location, at this location, at any location, if I want to find out the pressure intensity acting on that, because of that fluid, then that will be given by hydrostatic law. So according to hydrostatic law, the rate of change of pressure, according to hydrostatic law, the rate of change of pressure in a vertically downward direction is equal to weight density of the fluid. According to hydrostatic law, the rate of change of pressure in a vertically downward direction is equal to weight density of the fluid. That means here rate of change of pressure means delta P in a vertically downward direction. Here, if I am considering vertically downward direction as the Z direction, or instead of Z, you can consider as H also. So delta P by delta Z, that is called as the rate of change of pressure in the vertically downward direction. That is equal to weight density. That weight density is nothing but small w. That is also called as a rho g. So delta P by delta Z. So this is the statement of hydrostatic law, or this is the expression for hydrostatic law. Means change in pressure in a vertically downward direction is equal to weight density of the fluid at that point. So based on that hydrostatic law, you can find pressure variation in a static fluid. Based on hydrostatic law, you are able to find out the pressure variation in a static fluid. So we are knowing that pressure variation in a static fluid is given by equation P is equal to rho g into Z. Whereas P is nothing but pressure intensity at any point in a static fluid. P is called as pressure intensity in a static fluid. Rho is called as the density of that fluid. G is nothing but gravitational acceleration, and Z is nothing but the vertical distance from the free surface. It is also called as the head. So instead of Z, you can use the H also. That is nothing but P is equal to H. So here H or Z will be also given by equation P upon rho G, whereas rho G is also called as a specific weight. So this is called as the hydrostatic law. Now based on the hydrostatic law and based on the Pascal's law, we have to solve the questions. So you should be along with pen and paper. So first question: the hydrostatic law states that the rate of increase of pressure in vertical direction is equal to option A is density of fluid, option B is specific weight of fluid, option C is nothing but weight of fluid, and D is nothing but none of above. So you have to give the answer in chat box. Good day, sir. Good day, sir. Okay. Give the answer in the chat box. So question is visible to you. The hydrostatic law states that rate of increasing pressure in particularly downward direction is equal to. So students are giving the answer. Give the answer in the chat box. So only definition they have asked. The hydrostatic law states that rate of increasing pressure in particularly downward direction is equal to weight of the fluid. So option B is the correct answer. Then next question: Pascal's law states that pressure at a point is equal in all direction. Option A is in a liquid at a rest, in a fluid at a rest, in a laminar flow, in a turbulent flow. So this question is a slightly tricky question. You have to give the answer correctly. First law states that pressure at a is equal in all direction. Option A in liquid at a rest, in a fluid at a rest, in a laminar flow, in a turbulent flow. Give the answer. Remaining student, you have to also give the answer. So by mistakenly, some student in a hurry make the answer in a liquid at a rest, but the correct answer is whatever Pascal's law is there. That Pascal's law is applicable for all the fluids which are in rest. So instead of liquid, because fluid may consist as a liquid gases. So here correct option is nothing but option B. It is nothing but in a fluid at rest is the correct answer. Now next question. Hydrostatic law of pressure is given as. So this is the question which was asked for IES 2002. Options are given. Dabba P by dabba Z is equal to rho G. Dabba P by dabba Z is equal to 0. Dabba P by dabba Z is equal to Z. And dabba P by dabba Z is equal to constant. So whatever equation related to the pressure variation in static fluid we are getting, P is equal to rho G. That equation we are getting after integrating the hydrostatic law. So option, most of the students are writing option A as the correct answer. So correct answer is nothing but option A, that is nothing but dabba P by dabba Z is equal to rho G. So if you are going to integrate this equation, then automatically you will get the value of pressure variation in a static fluid. P is equal to rho G Z, or instead of Z you can use as a word as a H. P is equal to rho G H. Then next question. So this is the question which was asked for IES 1996. So two lists are provided. So first list is related to the law. Whatever second list is there, that is related to the phenomenon. And you have to select the correct answer using the code given below in the list. So in the list 1, they have hydrostatic law, Newton's law, Pascal's law, and Bernoulli's law. And in list 2, I have mentioned that pressure at a point is equal in all directions in a fluid at a rest. Shear stress is directly proportional to velocity gradient in a flow, and rate of change of pressure in a particular direction is proportional to the specific weight of fluid. To give the correct answer. So whenever such type of pattern will be there, then you have to use the elimination method. That means one option you have to eliminate, and at the end you have to come to the correct answer. Many of the students are writing the same answer. For everyone, and you are getting the same answer. So hydrostatic law, we are knowing that hydrostatic law is nothing but a rate of change of pressure in a particular direction is proportional to the specific weight of fluid. So for A, option 3 is the corrected one. So option 3. So only option B is there. So if you are confident about your first answer, that is hydrostatic law is nothing but option 3. So there should not be necessity to check the another answer also, because in most of the competitive exam you have to solve one question within 1 minute or less than 1 minute. So there you have to use the that option elimination method. So option B is the correct answer. Last question. Okay, this is a challenging question. The standard sea level atmospheric pressure. The standard sea level atmospheric pressure is equivalent to 10.2 meter of fresh water of rho is equal to 998 kg per meter cube. 10.1 meter of salt water of rho is equal to 1025 kg per meter cube. 12.5 meter of kerosene of rho is equal to 800 kg per meter cube, and 6.4 meter of carbon tetrachloride of rho is equal to 1590 kg per meter cube. This is the question which was asked for IAS 2000. So if you are having the basic knowledge, then and then only you are able to solve this question. Otherwise, your answer will be wrong. And my guess is that most of you will give the wrong answer for this question. Take your time, find out the trick, how to find out the atmospheric pressure, and then give the answer. Because we are knowing that standard value of atmospheric pressure is nothing but 10.33 meter of water, which is nothing but 760 mm of Hg, which is nothing but equal to 1.01325 bar, or 1.01325 into 10 raised to 5 Newton per meter square. Take your time, solve the question, and then give the answer. Most of the students are writing the option A as the answer. Written B, Yadikar. You have also written B. Vinay, can you hear me?
Yes, sir.
Abhinay,
Yes, sir.
can you give? Can you tell why you are written as a B as option?
Sir, atmospheric pressure is 1.013 bar.
Ah,
That's equal to 101 Newton per 101,558 Newton per meter square.
okay.
And we have one, and
10.
in 101
What you are telling?
in Newton per meter square. If we 1.013, if we convert it into Newton per meter square, it will become
Okay,
10.
that will become as a 1.01325 bar. Oh, sorry, 1.01325 into 10 raised to 5 Newton per meter square.
Correct.
Ah,
But in option B, it is 10.01, and according to formula of pressure, rho GH.
yeah, E is equal to rho GH.
We have
Okay.
we wanted to calculate H. We have G.
Okay.
We have
You are
102.
knowing the value of G as a 9.8.
And by putting into that formula, it will approximately come to 10.1 meter.
So your answer is correct, and your method of solving the question is also correct. So we are knowing that atmospheric pressure, standard value of atmospheric pressure is nothing but 1.01325 bar. That is nothing but 1.01325 into 10 raised to 5 Newton per meter square. If you see the option here, in each and every option they have provided the value of H. Here 10.2 meter of fresh water, 10.1 meter of salt water, 12.5 meter of kerosene, 6.4 meter of carbon tetrachloride. Those are nothing but H. And for each and every liquid they have mentioned the value of rho. So here we are knowing the formula P is equal to rho GH. We are knowing the formula P is equal to rho GH. Whatever may be the liquid, whatever may be the liquid, that may be the fresh water, that may be the salt water, that may be the kerosene, or that may be the carbon tetrachloride. For each and every liquid or for each and every fluid, the value of standard atmospheric pressure will not go on changing. That means for each and every equation, that means for each and every fluid, you should get the value of P. That is nothing but standard atmospheric pressure as a 1.01235 bar, or 1.235 into 10 raised to 5 Newton per meter square. So here as P is equal to rho GH. So value of rho for each and every fluid they have mentioned, value of G you are knowing, and value of H for each and every fluid they have mentioned. So if you are going to do the calculation, that is rho into G into H for each and every fluid, and if your answer is getting as a 1.125 into 10 raised to 5 Newton per meter square, then that is the correct answer. So here for option B, that is for H is equal to 10.1, rho is equal to 1025, and G is equal to 9.81. If you are going to go P is equal to rho GH, so putting the value of rho as a 1025, G as a 9.81, H as a 10.1, you will get the answer of P as a standard atmospheric pressure. So here calculate. Here you require to calculate the value of pressure for each and every fluid. Value of pressure for each and every fluid. म्हणजे फर्स्ट फ्लुइड साठी काय येणार आहे 998 into 9.81 into 10.2 हे काय येणार आहे प्रेशरची व्हॅल्यू. ही स्टँडर्ड ॲटमॉस्फेरिक प्रेशरची व्हॅल्यू आहे का नाही. सो value of standard atmospheric pressure nearer to standard atmospheric pressure is nothing but 1.01 into 10 raised to 5. So here 101558 Newton per meter square. So option B is the correct answer. Are you getting everybody? Give the comment, yes or no, whether you are getting the solution. Okay, so next one is related, or next point is called as the absolute pressure and gauge pressure. So most of the time for your campus recruitment test, most of the time question will be asked related to the absolute pressure, gauge pressure. So in the class also, actually this point was not in our fluid mechanics syllabus, but as a basics we need to cover. So absolute pressure and gauge pressure. So we are knowing that atmospheric pressure, we are knowing that whatever atmospheric pressure is there, that atmospheric pressure is nothing but the pressure which is caused because of the matter which is present on the atmosphere. Atmospheric pressure is nothing but the pressure which is caused because of the matter which is available on the earth's surface, that is called as the atmospheric pressure. So another term is there called as the absolute zero pressure. Another term is there that is called as the absolute zero pressure. So we are knowing the value of atmospheric pressure. Value of atmospheric pressure is nothing but 1.01325 bar, or which is nothing but equal to 10.33 meter of water, or which is nothing but equal to 760 mm of Hg. So if I am going to reduce the pressure, so we are calling that below atmospheric pressure there will be the vacuum pressure. So if I am going to reduce the pressure, so one point will come where the pressure will become as a zero. So that pressure will be called as the absolute zero pressure. Actually this absolute zero pressure condition will not be, or that absolute zero pressure condition will never be attained. Absolute zero condition means, absolute zero pressure condition means whenever there will not be any form of matter, whenever there will not be any form of matter on the earth's surface, that means there should not be anything on the earth's surface, then whatever pressure will be existing on the earth's surface, that will be called as a absolute zero pressure. So as absolute zero pressure is a term is never been attained, that's why we are always using the term as a partial pressure or partial vacuum pressure. So here whatever gauge pressure and absolute pressure terms are there, whatever gauge pressure and absolute pressure terms are there, those are related with the atmospheric pressure. That means if you want to measure the pressure, And while measuring the pressure, if you are going to consider atmospheric pressure as a datum line, for measuring the pressure, if you are going to consider atmospheric pressure as a datum line, then whatever pressure you are going to measure, that will be called as a gauge pressure. So suppose you are having any equipment, and or suppose you are having what we can say piston cylinder assembly or anything pressure vessel, and their pressure is suppose 2 bar, and if you are measuring the pressure by considering the atmospheric pressure as a datum line, that means there you have to consider atmospheric value as a 0, that means negative gauge pressure. And here, if you are measuring the pressure, if you are measuring the pressure by considering the absolute zero pressure line as a datum line, absolute zero pressure line as a datum line, then whatever pressure you are going to measure, that will be called as the absolute pressure. So here in this diagram, this line is indicating the atmospheric pressure. This line is indicating the atmospheric pressure. This line is indicating the pressure having value is equal to 0. That means absolute zero pressure. Here on y-axis, I have taken the pressure. So here for point A, if I want to measure the pressure, for point A, if I want to measure the pressure, then I can measure the pressure at point A by two ways. First one is by considering the datum line as the atmospheric pressure. Second one by considering the datum line as the absolute pressure. So if I am going to measure the pressure at point A by considering the atmospheric pressure as a datum line called as a gauge pressure, by considering the absolute zero pressure line as a datum line, then that will be called as the absolute pressure at point A. Second thing, suppose point B, if I want to measure the pressure at point B, so as point B is below the atmospheric pressure line, point B is below the atmospheric pressure line. So here, if I am going to measure the pressure at point B by considering the atmospheric pressure, then that will be called as a negative gauge, that is also called as the gauge pressure. Sorry, negative gauge, or that is also called as the vacuum pressure. And if I want to measure the pressure at point B by considering the absolute zero pressure line as a reference line, then that will be called as the absolute pressure at point B. So here you have to always remember that. Always that may be positive, may that will be always positive, because will always be positive, because we are considering the absolute pressure by taking reference as a absolute zero pressure line. Two formulas. First formula, this formula is very much important. If I want to measure absolute pressure at any point, if I want to measure absolute pressure at point, then absolute pressure at any point will be given pressure and gauge pressure. So when to use the plus sign and when to use minus sign. So I'm going to use the plus sign if I am going to measure the pressure above the atmospheric line. And if I'm going to use the minus sign if I'm going to measure the pressure of the point below the atmospheric pressure line. So absolute pressure is equal to atmospheric pressure plus minus gauge pressure, plus sign for pressure above the atmospheric pressure, minus sign for pressure below the atmospheric pressure. And if I want to measure the vacuum pressure, if I want to measure the vacuum pressure, will be given by equation atmospheric pressure minus absolute pressure. Atmospheric pressure minus absolute pressure. So that will be the formula to calculate the vacuum pressure. So this is the term called as the absolute pressure and gauge pressure. So related to the absolute pressure and gauge pressure, we have to take some note. So first point, the value of atmospheric pressure, value of atmospheric pressure at mean sea level at 15 degrees centigrade. Value of atmospheric pressure at mean sea level at 15 degrees centigrade is always equal to 101.3 kilonewton per meter square. That is nothing but equal to 10.13 Newton per centimeter square. So this unit conversion you have to always keep in mind, 101.3 kilonewton per meter square, which is nothing but equal to 10.13 Newton per centimeter square. In case of MKS unit, that value of atmospheric pressure will be given as 1.033 kgf per centimeter square, kgf per centimeter square. And second point, you have to keep in mind that the value of atmospheric pressure in terms of mm of Hg is nothing but 760 mm of Hg, and in terms of meter of water, that is nothing but 10.33 meter of water. Are you getting? Those are the points related to the absolute pressure and gauge pressure. Now we have to solve the problems based on the absolute pressure and gauge pressure. So first question, the reading of pressure gauge fitted on a vessel is 25 bar. The atmospheric pressure is 1.03 bar, and the value of T is 0.81 meter per second square. The absolute pressure in a vessel is, so this is the question which was asked for IES 1994. So 20.97 bar, 25.603 bar, 34.84 bar. You have to give the answer. I request everybody, don't leave the meeting, because at the end I'm going to take the attendance, taking the recording. The meeting in between, then you may absent. Here some students are writing it is nothing but 26.03 bar. First of all, read over that question and after that give the answer. So they have mentioned on a vessel, it's indicating the pressure equal to 25 bar. That is nothing, and atmospheric pressure is nothing but 1.03 bar. For the pressure values they have provided in terms of bar, the value of G, for confusion, value of G is 9.81 meter per second. So here they have given the value of G as 9.8. Means you have to use the value of that G while solving the question, but that will not be for confusion purpose. Sometimes they are going to mention likewise. So here they have mentioned that they have asked us find out the absolute pressure in the vessel. So always you have to stick with the basic. So as we are knowing that absolute pressure is nothing but gauge pressure plus atmospheric pressure. Absolute pressure is nothing but gauge pressure plus minus absolute absolute pressure is nothing but atmospheric pressure plus minus gauge pressure. So when to use the plus sign, if that pressure value is greater than atmospheric pressure, you have to use the less than atmospheric pressure. So here pressure is 25 bar and atmospheric pressure is 1.03 bar, 3 bar. So absolute pressure is nothing but atmospheric pressure plus gauge pressure. So here correct answer will be 26.03 bar. That is nothing but option C. And why? Because you are knowing that absolute pressure is nothing but atmospheric pressure plus gauge pressure, which is nothing but 25 plus 1.03, which is nothing but 26.03 bar. Next question. This is also very much interesting question. So I think that by considering the level of question, okay, let's check how many students are giving the answer. The barometric pressure at the base of mountain is 750 mm of Hg, and at the top of mountain is 600 mm of Hg. Because we are knowing that there is a pressure variation as far as height is concerned. So barometric pressure at the base of 750 mm of is 600 mm of Hg. Approximately. For UPSC in 1998 IAS exam. So knowing the pressure in a static fluid, here you have to consider whatever atmospheric air is there, that atmospheric air is acting as a static fluid. So one mountain is there, at the base of mountain pressure is 750 mm of Hg. At the height of mountain or at the top of mountain pressure is 600 mm of Hg. You are knowing that there is a variation of pressure height is concerned. P is equal to rho GH. So they have mentioned the density of air also. So here you have to find out the height of mountain. You can take 2 minutes for solving this question. विवेक रोंगे विवेक विवेक आहे का give the answer are you able to solve the question give your answer in the comment box yes or no if you are not able to solve the question then we will see the answer are you trying for solving the question give some answer yes or no are you trying to solve the question or should I display the answer have you understood the question at least there is one mountain at the base of mountain pressure is nothing mm of Hg of mountain pressure is nothing but 600 mm of Hg They have mentioned the density of air 1 kg per meter cube. That is nothing but the average density. So here you have to find out height of the mountain approximately, not accurate, but approximately. At least tell the answer whether you are able to solve the question or whether you are trying to solve the question. Height is 2037 meter. Shraddha. Can you tell or can you elaborate your answer?
Hello, sir.
Huh.
Hello. Sir, actually, I
Huh. You
converted
can tell
that.
the answer. Your answer is correct one.
Yeah, I converted that means Hg column into kilonewton per meter square. That is, first one will be 99.99 kilonewton per meter square at the base, and at top it will be 79. So I use that formula, delta P by delta Z is equal to rho G. So kept that value, a difference between delta P, and then I got that delta H.
Okay. Your way of solving the answer is also correct, and your answer is also correct. So correct answer is nothing but option A. Here, as they have asked approximately, that is nothing but approximately. That answer is nothing but 4,000 meter. How to solve this question? So first of all, we are knowing the pressure difference. They have mentioned that pressure head at the bottom of the or at the bottom of the mountain or at the base of mountain and at the top of mountain. So here whatever pressure difference will be there at the bottom or at the base and at the top, that will become as a 750 minus 600. That is nothing but 150 mm of Hg. 150 mm of Hg. That is nothing but the pressure head difference. 150 mm of Hg is nothing but the pressure head difference between base of mountain and at the top of mountain. But that G in terms of meter of air. So how to convert that mm of Hg in terms of meter of air? So 150 mm of Hg, 150 mm means 0.150 meter of Hg will become. And here if you are going to multiply that density of Hg by that 0.150, you will get that height of that mountain. So here, correct answer or correct value is nothing but 2040 meter. Shraddha, what was your answer? 2040.
2037.
Okay, that means your answer is also correct. So here you will get directly the value of H, that is nothing but 2037, which is nothing but equal to 2040, which is nothing but equal to 2000 meter. So this is the question related to the absolute pressure, gauge pressure. Now next point is nothing but measurement of pressure. So here we have to check we have to see the or we have to study the pressure measurement devices, that is called as a manometer. So what is now? I think time is 5 p.m. So here we are going to end our lecture. Don't leave the lecture. I am going to take the attendance. Wait for 1 minute only. So in the next lecture, we are going to study related to the manometers. What are the types of manometer and how to calculate the value of pressures by using the manometers. Wait for 1 minute. I'll stop the recording first.